Welcome to Krishna's online lectures. In today's video, I am going to discuss about differential manometer. Differential manometer is a type of manometer which generally used to measure the difference of pressure in a pipe or in two different pipes. This is the topic of pressure and its measurement. Now let's start our video. So here I will discuss about differential manometer. So as I told you about the differential manometer, see this particular device is generally used to measure the difference of pressure between two points in a pipe or in two different pipes. So let us consider a pipe, and if we are considering two different points in a pipe, so we can measure the difference of pressure in that 2 points of pipe. Or if we are considering two different pipes and two different points in a pipes, so we can find out the difference of pressure for that particular condition. So differential manometer is generally used to measure the difference of pressure between 2 points in a pipe or in two different pipes. And there are two types of differential manometer we consider. One is the U-tube differential manometer and another is the inverted U-tube differential manometer. So the exact shape of this differential manometer is related to U-tube manometer only. This is the diagram of U-tube differential manometer, and inverted U-tube differential manometer is just opposite to this. We use inverted U-tube to find out the difference of pressure. So there are two types of differential manometer. So as per this U-tube differential manometer, we can define the constructional detail of this differential manometer. See, it consists a U-tube, and in this U-tube we generally consider a heavy liquid. This U-tube is filled with a heavy liquid like mercury, and there are two limbs of the U-tube, left limb and the right limb. So these two limbs are connected to two different points where we have to measure the pressure, or we have to measure the difference of pressure of these 2 points. Like here this left limb is connected to the point A, so we will find out the pressure at point A, and this right limb is connected to point B, so we will find out the pressure at point B. And then with the help of this PA and PB, we can find out the difference of pressure. So this is about the differential manometer. Now let's discuss these two different types of U-tube differential manometer. So first I will discuss about the U-tube differential manometer, and in next video I will discuss about the inverted U-tube differential manometer. So let's discuss the U-tube differential manometer. So there are two conditions I am going to discuss in this video. One, when we have to find out the pressure between, or the pressure difference between 2 points which are at the different level, and it is connected to differential manometer. And another condition is when these 2 points are at the same level. So here we will use the U-tube differential manometer to find out the pressure difference. So let's see the first condition. So in this first condition, you can see this diagram. Here we are considering one U-tube, and the heavy liquid is filled into this U-tube, and the left limb is connected to the point A, and the right limb is connected to the point B. And you can see here this point A and point B are at the different level. Okay, there is some level difference between point A and point B. So here we have to find out the difference of pressure in point A and point B, and it is connected to one U-tube manometer. Okay, one U-tube. So first we will see the liquid which is we are considering at point A. It is having density, some density, and this density of the liquid in this pipe A we are considering that is different from the density of the liquid which is in pipe B. So in both pipes we are considering different liquids. So let us see here. This height h is representing the difference of mercury in U-tube. You can see here this h. This h is representing the difference of height of mercury in this U-tube. See, as I told you in previous lesson, that we first consider one datum or the point where we are considering the same pressure. So this XX line is representing the datum line, and at these two particular points, we will consider the pressure is same, and we will apply the Pascal's law here, and with the help of this Pascal's law, we will find out the pressure or the difference pressure. So this XX line we are considering as the datum line, and from this datum line to the highest level of mercury in the right limb, because in left limb there is no mercury, and in the highest point of the mercury is this in right limb. So from datum to a highest point of the mercury in right limb we are considering as H, or the difference of level of mercury in both the limbs is H. And the second is Y. So this Y distance is representing, you can see here, the distance from HD or mercury level to the center of point B in the right limb. This is limb. This is limb. Okay. So from point B to this point, we are considering distance is Y. Similarly, from point A to highest level of mercury in right limb, we are considering distance, that is X. X we are considering as distance from HG level to center of A in the left limb. Okay. Now, as I told you, the density of both the points, or density in both the point, density of liquid is different. So ρ1 we are considering the density of the liquid in pipe A. This is the different liquid and this is different liquid, and in pipe B we are considering density ρ2, and density of heavy liquid or mercury we are considering ρg, and the pressure at point A and point B we are considering PA and PB. Okay. So here, when the points A and B are at the different levels, so we will find out the pressure PA and then PB, then we will find out the difference of pressure. So as I told you about the line XX, this is the datum line, and first we will find out the pressure in left limb. So in left limb we are considering the point A. So at point A the pressure is PA. So the pressure will be PA plus the distance we are considering, that is X, and H up to datum line. Up to datum line we are considering the height. So X is representing the difference between this particular point A and the highest level of mercury, and the difference of level of mercury in both the limb is represented by H. So first pressure in left limb will be what? Point A pressure, PA, plus next pressure is ρ1. At point A we are considering density ρ1, so it will be ρ1 G H plus X. This is the total, this limb is filled with this liquid with density ρ1. Okay, so it will be ρ1 G H plus X plus PA in left limb. Similarly, in right limb, the concept to find out the pressure in the right or left limb is same, similar to previous one. So in right limb, the pressure will be what? It will be PB plus, there are two liquids in this right limb, the liquid with density ρ2 and the liquid with density ρg. So it will be PB plus ρ2 y, this ρ2 y into G plus ρg into G into H. So this is the pressure above the XX in the right limb. Now, as per the Pascal's law, we will equate these two pressures. So we will equate these two equations. Our equation will be this, and then we will simplify this equation. So the difference of pressure will be PA minus PB will be HG ρg minus ρ1 plus ρ2 gy minus ρ1 gx. So this is the difference of pressure at point A and B. Now similarly, if we want to find out the pressure difference for the second condition, when this point A and point B are at the same level, so in that particular condition, we will find out the pressure in the left limb, then pressure in the right limb, and then we will equate both the pressure. But here we are changing the condition. See, the point A and point B are at the same level, but the liquid in pipe A and pipe B is same. It means the density of liquid in pipe A is similar to density of the liquid in pipe B. Means both the liquids are same. So here for this particular condition, we have to find out the difference of pressure. Here at point A, we will consider pressure PA. At point B, we will consider pressure PB. And this U tube contain mercury. So here XX we are considering as the datum line, and the total level difference of the mercury in both the limbs we are considering as H. And from point B to the highest level of the mercury in the right limb we are considering as X. Okay, so this is the distance in right limb we are considering. For X distance for the liquid level in pipe B, and H we are considering as the difference of level of mercury in both the limb, and in left limb we will consider the total distance from point A to the this particular highest level of the mercury in the left limb, that will be X plus H only. So first we will find out the pressure above the datum line XX in the right limb. Okay, we can find out the left limb or we can find out in the right limb, whatever you want. Okay, so first here we are finding out in right limb. So in right limb we are considering pressure PB. So it will be PB plus for density rho 1. So it will be rho 1 G into distance is X plus rho G into G into the distance is H. So this is the pressure in the right limb above XX. Okay. Now similarly in left limb, the pressure will be what? It will be the pressure we are considering at point A is PA. So it will be PA plus, and the total distance is X plus H. So it will be rho 1, density is rho 1 into G into H plus X. So this as per the Pascal's law, if we equate these two equations, so our equation will be this in right limb and in left limb. So it will be uh, the equation, this equation we will simplify. So we will find out the pressure difference, that is PA minus PB is equals to this rho GGH plus rho 1 GX minus rho 1 GH plus X. So the simplified equation will be this PA plus PA minus PB, that is equals to rho G minus rho 1 GH. So this is for the second condition, difference of pressure for the second condition. Thank you so much for watching this video. You can subscribe to channel for more videos related to mechanical engineering. And if you want to attend online live classes or courses which is related to your competitive exams for the mechanical engineering like GATE, ESE, RRB, JEE, SSC, JEE, etc. So you can contact me on this mail ID krishnaonlinelectures@gmail.com, or you can message me on this WhatsApp number 93722 76663.